Hello and welcome back to Just Code It. Today we're starting a new semi-series as it pertains to LangGraph, where we're going to take a little tangent and basically go through some of the most common design patterns when creating agents. The first one we're going to start out with is the routing design pattern. You'll probably recognize these because we've been using them, but now we're actually going to put a name to them, and you can solve 90% of all problems with these. Honestly, probably 99% of all problems with just these. But main agent types or agent design patterns are just prompt chaining, that's just lang chain. And then we have parallelization, which is just sending mini tasks out and then coming back. Then we have routing, which we're doing today. Then we have an orchestrator, where each node can go to another node and you have a bunch of agents that can make decisions. Then also we have an evaluator, which you get a generator that generates something, and then you have another agent that is set up to evaluate that one, and it either rejects or accepts it. That being said, though, let's actually jump into how to actually create a router. This might seem a bit familiar to you all because it's a lot like the supervised, or was that what it was called for one of the last episodes? I think it was, yeah, it's supervised, where you have a supervisor that goes out and it routes the traffic, but another term for it is router. I actually noticed that LangGraph actually uses it more as a router. I read somewhere that it said supervisor, but I guess it's interchangeable. This is the graph we're going to create today. Zoom in on it. Oop. The router we're creating is we're going to have the top level router. It's going to make the decision to either go code. You can think of these as topics, and you'll have a specialized agent for that specific topic. It's almost like you can create your own mixture of experts model by using these agents in a way. You can have multiple different agents that specialize in something like the experts, but what the router is going to do is decide which path or which expert it's going to use, and then it's going to end up at the end. But you could have it loop back to the router if you want to. This is just an easy example where we're just flowing straight through and just having the router make a decision. Because each decision, if you even loop back up, it's going to be making the same decision. Let's run the first one. We just have our imports. Then we have our state. Our state is going to have a query, a route, a response, and the reasoning for its response or reasoning for its route. After creating our state structure for the graph, we're then going to come down here and just create responses from LLMs. We're not actually going to implement this node where it's going to actually perform an action, like a creative, a code, a general action. We're just going to use the LLM to perform the router just to save some time. The API response is just going to be a hard-coded response, so we know what route it took. Coming down here, we then have the route query. What the route query does is it routes the query to a specialized agent. You can uncomment this if you want to use OpenAI. And then how we do this is we grab the query from the state, we create our LLM, and then we create a system message using system message from LangGraph. And then our system message is a long message. It's just giving it its options, giving a definition of each one of the options, and then it's telling it to respond in a JSON object. Then we come down here to the human message, where we generate a human message using that query. To get the logic here, we run the LLM. We do LLM invoke. We pass it the system message, and we pass it the human message. The order here matters. After you get the response, we're going to normalize the data because we don't want it capitalizing sometimes, lowercasing other times. We're just going to normalize that data, then give us some default values for the route and reasoning. Those are the two things we're going to update on the state. Finally, we're doing a try except, where we're going to try to do the JSON loads and then give it the text to grab the data. And then we're going to try to grab the route and the reasoning from that JSON object. But because we're using an LLM, they can mess up and they don't always get JSON objects correct. There's a clever way that you can, if you're using like very specific keywords that you know that the LLM is probably going to respond with, you can, even if the object fails there, you can just interact with the JSON object as a string and just look through that string and parse it a little bit and get to the right answer. For this example, you can, but not for all of them. That's what we're doing right here, though, is just our fallback. Finally, we just update the route and the reasoning and return the state. Let's keep moving down where we are starting to make our agent nodes. Let's pull this out, actually. After creating the agent state, we're then going to move on to this mock data right here. Each one of these nodes, or actually not the nodes, they're the agent interaction that would happen at that node. Instead of actually reaching out to the LLM and answering a question, we're just going to create a fake API and call these. We know what we're getting back. And we're just going to return a hard-coded string. Come down a bit more. This is the important one. This is the router right here. This is where all the logic is happening. The LLM's performing most of the logic for us, but we're setting up the structure for querying the LLM here. We do this is we create a query, grabbing the query from the state. We're using Shadow Llama and then Llama 3.2. You can uncomment this if you want to use OpenAI. We create the system prompt or the system message. This is pretty important, but I'm not going to read it verbatim. What this is saying is we're giving it its options. We're giving it the definition of the options, code, math, creative, and we're telling it you need to respond in a JSON object and giving it an example. A pretty standard prompt structure. Then we come down here and create a human message with our query. We invoke the LLM using LLM invoke and pass it the system message first, and then the human message in a list. After we get the response from that, we're then going to normalize the data and create our default values for route and reasoning, because these are the two values on the state that we're going to be updating. Then we come down here to this try except, where we first try to load the JSON string into an object. If that does succeed, we then grab the route and the reasoning. If it doesn't succeed, we then come down here and we know what's going to be in this JSON object, even though it might not be syntactically correct. What we're doing is just looking for these words and then returning them. We know it's probably not going to mess up on that. It's probably going to mess up on a bracket. Then come down here, update the state and return the state. Let's keep it moving down to the nodes now. These are all the nodes right here, the code, create, general, and math. Nothing special here. Again, no logic going on here. We're just calling those fake APIs where we're going to grab the response, update the response, and return the state again for all of them. The important part is understanding how this router saves you a ton of if statements, parsing a query and picking a agent. You're using the LLM's reasoning ability to do that for you. That is the real power of the router. This is just normal. Finally, we're actually going to start constructing this graph. We just have this helper function up here, which takes in the state and returns the route. Nothing real special here. We just use this for the conditional. And we have another method that actually creates the agent or the graph. We're going to create a workflow, state graph workflow, agent state, the initial state. We're going to add a node for router, the top one, and then code, math, create, and general. After that, we're then going to create the entry point. And finally, we get to something that's not standard, where we're adding a conditional edge. The conditional edge starts at the router, and then it uses this method to just grab the route from the state, returns that there. We're then going to create the conditional edge, which starts at the router, and we use that helper function to grab the route from the state, which is going to return code, create, general, or math. And then we have the mapping for the routes and edges. Finally, we have all these end or termination edges where we go from code to end and all of them to end. We compile it and return it. Let's run that one. Then we come down here, we can print the graph. Next, we're actually going to create some examples. We have how do I implement a binary search algorithm in Python for number one. And we have some math for number two. It should go math. Then we're asking it to write a story. Hopefully it goes creative. What causes the northern lights? Let's hope it goes general. I'm hoping it goes general on that one. The second to last one, we're going to go for code again and then math again. We have a mixture and hopefully it actually works. Oh, going pretty fast. If it doesn't work with a smaller model, it's also good to just use a bigger one. That's a bit more intelligent, but it looks like it's actually working. We have code. That's what we said for the first one. Oh yeah, I put it right here. Code. And then we have, yep, math, create, cool, general, yep, and code again. And math. Wow, I actually got them all right. It's a good little model. Llama 3.2. All right. That is it for this first installment of these design patterns that are frequently used in LangGraph, and honestly all around creating agents, not just LangGraph, but frequently in LangGraph as well. Up next, we are going to do the parallel design structure, or the parallel design pattern, where it sends out a bunch of smaller tasks and then they come back to create a bigger task. If you have any questions on this, please comment down below. I also have a post up if you want to vote on the next topic we do. Feel free. Or if you want to recommend a topic that we do next, because we're coming to the end of LangGraph. That is it for today, though. I hope you enjoyed today's video, and I'll see you next time.